All right, here are the review questions for Chapter 2. First one, construct a frequency histogram for the data set using 7 classes. So the first thing we have to do is find the minimum and the maximum. The minimum is 11.86, the max is 12.1. So we take that and divide it, or we take the difference of that, so 12.1 minus 11.86 gives you 0.24. You divide that by 7 and then round up. So it's going to be 0.04 is your difference between classes. So in order to do a frequency histogram, first we have to do a frequency table. Let's size that down a little bit. Okay, so we start with the lowest number, which is 11.86. Then you add 0.04 to that. That's going to give you 11.9. Then 11.94. Then 11.98. Then 12.02. And 12.06. And the last one will be 12.1. Then this is going to go up to 11.89, 11.93, 11.97, 12.01, 12.05, 12.09, and then 12.13. Now we'll just figure out which data falls into where. So to find the frequency, I'm actually just going to do it the easy way. 11.95, 93, 99, 94, 98. First column's done. 91, 12.0, 94, 89, oops, I jumped into the other column. Anyways, I know this 89's out. So it's 92, 92. This column's done. 11.86, 94, 98, 95. That one's done. 94, 12.1, 12.01, 11.88, 11.93, 12.0, 11.95, 11.99, 11.94. All right, so that should be all of them. So our frequencies are 3, 5, 8, 7, 0, 0, 1. Now when we do a histogram, remember you can start with the bottom number, or you could use the middle or the top. Doesn't matter. I'm going to start with the bottom. 11.86, 11.9, 11.94, 11.98, 12.02, 12.06, and 12.1. So it goes up to 3 for the first one. Imagine your histograms are going to look a lot like this. Just make sure you keep the bars touching each other. Goes up to 5. And up to 8. And up to 7. 0, 0, and 1. So there's your frequency histogram. Pretty easy overall. Okay, so for this one we have to construct an O drive. In order to do that, we have to find our classes, our frequency, and our cumulative frequency. And so if we start with our lowest number, that's 79, we do 166 minus 79 divided by 6. It gives you 14.5, so you round up to 15. So we take our lowest number, 79, we add 15 to it. So our first class is going to start at 79, then add 15. It's 94, then 109, then 124, 139, and 154. '93, 108, 123, 138, and 153, and then 168 for your high. Now we just start dividing the data into sets. 153, 104, 118, 166, 89, 104, 100, 79, 93, 96, 116, 94, 140, 84, 81, 96, 108, 111, 87, 126, 101, 111, 122, 108, 126, 93, 108, 87, 103, 95, 129, and 93. It's really the biggest hassle of the whole thing. All right, so it's 9, 12, 5, 3, 2, 1. Then you do your cumulative, which is 9, 21, 26, 29, 31, and 32. Okay. Now to set up your ogive, frequency up the left side, and then your bars across the bottom. Not really bars, but you do low points. Do 79, 94, 109, 124. Nice. 139, 154. And up the side, you do, say, 5, 10, 15, 20, 25, 30, 35. Okay, so you start at 9, make a point, then go up to 21, make a point. 109 goes up to 26, then 29, 31, and 32. And so your ogive just looks like this. If I could hit any of the dots. Well, obviously supposed to go through the dots, and that's it. Use a pie chart to display the data, describe any patterns. If I have you do this on the test, you won't actually have to draw it out. You just have to show me how to do it. So what you would do is you add 620. Hint, I'm not going to have you do this on the test. You use 620 plus 110 plus 50 plus 100 plus 130 gives you 1010. And then you do like 620 divided by 1010. It's going to give you 61%. So 61%. And you do 110 divided by 1010. Gives you about 11%. And 50 divided by 1010. It gives you 0.05, so 5%. 100 divided by 1010 gives you 0.099, so about 10%. And then 130 divided by 1010, and that's going to give you 12.8, so about 13%. And then you would just do a circle and figure out your angle measurements. Like I said, I'm not going to make you do that. One of these questions is not even on the test. So, number 12. Use a time series chart to display the data, describe any patterns. Same thing here. You're basically just doing a graph, like a line graph for the time series chart. Oh, there we go. So you're doing all your years down the bottom side and then percentages up to the top. The 2, 4, 6, 8, 10. And across the bottom, you do the years. It'll be 01, 02, 03, 04, 05, All right, then you just do your percentages. 4.7, about there. 5.8, a little higher. 6.0, a little higher. 5.5. I don't think I really need to illustrate this for you. You just do a line connecting all your dots as it goes through the time series. Again, not going to be on your test. 6 test scores are shown below. The first 5 scores are 15% of the final grade. The last score is 25% of the final grade. Find the weighted mean of the test scores. So you do 78 times 0.15 plus 72 times 0.15 plus 86 times 0.15 plus 91 times 0.15 plus 87 times 0.15, and then the final one is 25%, so you do plus 80 times 0.25. That's how you do a weighted mean. Now, since these are all times 0.15, you could have technically left the 0.15 out in front, added those all together, and then multiplied by 0.15. So you add this all together. And you get 82.1. And that would be the weighted mean. All right. Same thing here. We're talking about a frequency distribution shows the number of magazine subscriptions per household for a sample of 60 households. Find the mean number of subscriptions per household. You do the same thing. You do 13 times 0 plus 9 times 1 plus 19 times 2 plus 8 times 3 plus 5 times 4 plus 2 times 5 plus 4 times 6. Then you divide that by the total number, which is 60. And you get 2.08. Since this is magazine subscriptions, you could say 2, because you can't have a 0.08 for a magazine subscription. Number 21, this would be skewed left. 21 is skewed left. Number 22, your median would be the middle of your data set as far as the amount of people or the amount of respondents, or whatever this is talking about. And so it's probably going to fall down here further than the mean, which would fall up here a little bit more. You could calculate this out easily. I'm not going to have you do one of these, though. Is if you give me a description of why you would think that, then you'd probably get points for it. Calculating it out is really the only way to know. All right. I don't know what 27 is asking. Let's pull up the actual page. Find the range, mean, variance, and standard deviation. Good, this is a good one. You just put all these in your calculator. So you go into Stat, Edit. Do 5306, 6444. Okay, and go back into Stat, Calc, OneVer Stats, and that will give you everything you're looking for. So it wanted the range, that's just your max minus your min. So 6444 minus 4218, 2226. The mean is 5366.7. The variance is just taking the standard deviation and squaring it, sorry. So that would be your S of X in this case because it says it's a sample data set. So it'd be 649.7 or 649.8. So do 649.8 squared. That will give you 422,240.04. That is your variance. Standard deviation was just the number that we squared. So S of X, SX on your calculator, 649.8. All right. Number 30. Mean rate for satellite television for a sample of households was $72.50 per month. The standard deviation of $12.50 per month. Estimate the percent of satellite television rates between $60 and $85. Assume the data has a bell-shaped distribution. If it has a bell-shaped distribution, then it means it's the empirical rule. So we have to figure out how many standard deviations we're looking within. So if we do the mean or the median, either one, the mean, which would be 7250 minus 1250, it gives us 60. So that's one standard deviation below. $85 is one standard deviation above. Remember, 68% of your data falls within those two areas. And so that would be your answer, 68%. From a sample of households, the number of televisions are listed. Find the mean and the sample standard deviation of the data. Okay, for this one, you have to set up more than one stats list. So you do your number of televisions, 0, 1, 2, 3, 4, and 5. Go over to L2, 1, 8, 13, 10, 5, 3. For L3, I go up to L3 and I do L1 times L2 and now I do stat, calc, OneVer stats, hold on, that wasn't right, stat, calc, OneVer stats, think I can put in L3 and it'll tell me what it is. Yeah. So one Verstats in L3. So you just sample mean of 16.5. Sample standard deviation of 11.2. All right. Ages and years of experience for all lawyers at a firm are listed. If we go back to number 33 here, that didn't seem right with my sample mean being 16.5. It's not 16.5 TVs in the house. What you do to find the sample mean there is because it's a frequency distribution, you do the sum of x, which is 99, and you divide that by the number of households that they're looking at, which is 40. So you do 99 divided by 40, so you get 2.475 as your sample mean. Then to find your sample standard deviation, this is the one where we had to keep going with it. So you do x minus x bar, so it would be 0 minus 2.475, or you can go up to L4 and you just do second L1 minus 2.475, then enter. That gives you a new L4. Okay, then you do that, you go up to L5 and you do L4 squared. That gives you L5. Then you have to do for L6, L5, which is what you just found, times L2, which is your frequency, that gives you L6. And then we do stat, calc, one var stats of L6. You look at what your sum is, which would be 59.975, and then you divide that by 40 as well. Or you divide it by 40 minus 1, so 39. Guess what? This is also not on the test. I made your test pretty easy for you guys. I'm not going to lie. So you get 1.54 for your sample standard deviation. All right. With that in mind, we are not going to do 36. Same thing. You have to go through all those lists again. Draw a box and whisker plot that represents the data. Now we're getting back to the good stuff. So let's clear out all these lists. Stat edit. Clear. Okay, then we just enter these numbers in. And one var stats. And now we have our 5 points for the box and whisker. Q1 or your min, Q1, median, Q3, and your max. So we do a number line and just draw the box and whisker plot over it. I think most of you know how to do that. Weight in pounds of the defensive players on a high school football team are shown below. Draw a box and whisker plot that represents the data set and describe the shape of the distribution. I decided we might as well just do the box and whisker plot. What's the sense? So it would be, start with the lowest number, 42. Okay. So your lowest number gets a dot, your highest number gets a dot. Q1 is 47.5. That's looking like it's right here. Your median is 53. It's looking like it's right there. Q3 is 54. It's right there. So then we can connect them all. Then you draw a line to your dot. And that's your box and whisker plot. All right. Second one. Clear this list out. Enter this data in: 173, 145, 205, 192, 197. Enter all the data in, go over to Calc 1var stats, scroll down, we get the min is 145, Q1 is 173, median's 190, 208, and 240. So you need to go from 173 to 240. I'll make my bottom number here 170, 180, 90, 200, 210, 220, 230, and 240. So there's my max. My min's going to fall in here somewhere. Q1. Ah, snap. How did I mess that up? Jeez. So it goes from 145 to 240. So 140, 160, 180, 200, 220, 240. 145 is going to stay like right there. 240 is going to drop down to here. Just starts going. Q1 is 173. Fall in here somewhere. Median is 190. Like right there. Q3 is 208. Getting towards the middle there. It says describe the shape of the distribution. So if we look at this, our min and our max are about evenly distanced from the box. The median is about right in the middle of the box, so this would be a bell shape. Because all the data kind of falls, like median is directly in between the two dots. Q3, Q1 is close to the median. Median's about split between them, and then your dots are farther out, and they're about the same distance. All right, 45. First one, we have to find a z-score. It says towing capacity is mean 11,830, standard deviation of 2370. Transform the towing capacity to z-score, interpret the results, and determine whether the towing capacity is unusual. So we would start with 16,500 for number 45, minus 11,830, and you divide that by your standard deviation, which is 2,370. So you do 16,500 minus 11,830 gives you that, divided by 2, or by 2,370. And that gives you 1.97. So it's 1.97 standard deviations away from the mean, which means it falls within that 2 standard deviation range, so it's not unusual. All right. Number 48, you do 11,300 minus 11,830 divided by 2,370. So obviously going to be even less than 1 standard deviation. Divide that by 2370. So it says interpret the results. It's a little less than the mean, but it's not even 1 standard deviation below, so it's not unusual. All right, that is it.